let's consider some proposed changes to the National Electrical Code NEC. The first concerns Section 406.9c. The proposed change states a grounding terminal on a grounding type device shall not be connected to another terminal of the circuit unless approved for use as a grounding conductor. The reason for this proposed change is that the current language prohibits the grounding terminal of a grounding type device from being connected to another terminal of the circuit, even if the connection is made using an approved grounding conductor. This restriction is unnecessary and prevents the device from being used for its intended purpose. The second proposed change involves Article 100, definitions. Specifically, the addition of two new definitions: industrial site and commercial site. The proposed definition for an industrial site is a facility that processes or manufactures a product or product. The proposed definition for a commercial site is a facility that sells or services products or is otherwise involved with public or private services. The reason for adding these definitions is that they would provide a clear distinction between industrial and commercial sites, which is not currently defined in the code. This distinction is important because different requirements may apply to each type of site. For example, industrial sites may have more stringent requirements for electrical safety due to the presence of hazardous materials or processes. Let's elaborate further on Section 406.9c and the grounding terminal issue. The intention of a grounding terminal is to provide a path for fault current to return to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. This is a crucial safety feature that protects individuals from electric shock and prevents electrical fires. The current wording in the NEC, however, creates an ambiguity that can hinder the proper application of grounding techniques. For example, in some specialized equipment or installations, it may be necessary to intentionally connect the grounding terminal of a device to another terminal in the circuit through an approved grounding conductor. This might be done for specific functional reasons, such as reducing electromagnetic interference or ensuring proper signal grounding in sensitive electronic circuits. The existing code language could be interpreted as prohibiting such connections, even when they are implemented safely and in accordance with accepted engineering practices. By adding the qualifying phrase "unless approved for use as a grounding conductor," the proposed change clarifies that such connections are permissible, provided they are made with an appropriate grounding conductor that meets the requirements of the NEC. This allows for greater flexibility in the design and installation of electrical systems, while still maintaining a high level of safety. It is important to note that the term "approved" is used in the NEC to indicate that equipment, materials, or installations have been evaluated and found to be suitable for a specific purpose by a recognized testing laboratory or inspection agency. This ensures that any grounding conductors used in this manner meet stringent safety standards and are capable of safely carrying fault current. Now, let's turn to the proposed definitions for industrial and commercial sites in Article 100. The NEC currently lacks explicit definitions for these terms, which can lead to confusion and inconsistent application of code requirements. The distinction between industrial and commercial sites is significant because these types of facilities often have different electrical needs and hazards. Industrial sites, for example, typically involve manufacturing processes that utilize heavy machinery, high-voltage equipment, and potentially hazardous materials. These factors can increase the risk of electrical accidents and require more robust safety measures. Commercial sites, on the other hand, are generally focused on selling goods or providing services to the public. While they may still have electrical hazards, the nature and severity of these hazards are often different from those found in industrial settings. By providing clear definitions for industrial and commercial sites, the proposed changes would help to ensure that the correct code requirements are applied to each type of facility. This would improve electrical safety and reduce the risk of accidents. For instance, the NEC contains specific requirements for wiring methods, overcurrent protection, and grounding in industrial locations that are not necessarily applicable to commercial locations. Similarly, there may be requirements for emergency power systems or fire alarm systems that are more stringent in commercial buildings due to the presence of large numbers of occupants. The proposed definitions would also help to clarify the scope of certain NEC articles that apply specifically to industrial or commercial occupancies. This would make it easier for electrical designers and installers to determine which requirements are relevant to their projects. It is important to note that the definitions provided are intended to be broad and encompassing, covering a wide range of activities and facilities. The definition of industrial site includes any facility that processes or manufactures a product or products. This would encompass factories, manufacturing plants, refineries, and other similar facilities. The definition of commercial site includes any facility that sells or services products, or is otherwise involved with public or private services. This would include retail stores, office buildings, hospitals, schools, and other similar facilities. These definitions are not mutually exclusive, as some facilities may fall under both categories. For example, a manufacturing plant that also has a retail outlet on site would be considered both an industrial site and a commercial site. In such cases, the more stringent requirements of either category would apply. In summary, the proposed code changes aim to improve the clarity and applicability of the NEC. The revision to Section 406.9c would allow for greater flexibility in the use of grounding terminals, while the addition of definitions for industrial and commercial sites would help to ensure that the correct code requirements are applied to each type of facility. These changes would contribute to improved electrical safety and reduce risk of accidents. In addition to the specific examples mentioned earlier, there are several other ways in which the proposed code changes could impact electrical installations. For instance, the revised wording of Section 406.9c could affect the design of equipment grounding systems in industrial facility. In some cases, it may be necessary to intentionally bond the grounding terminal of a piece of equipment to another terminal in the circuit to reduce noise or improve signal integrity. The proposed change would clarify that such bonding is permissible, provided that it is done with an approved grounding conductor and in accordance with accepted engineering practices. Similarly, the definitions of industrial and commercial sites could affect the selection of wiring methods and equipment in different types of occupancies. For example, industrial sites may require the use of more robust wiring methods, such as rigid metal conduit or cable tray, to protect conductors from physical damage or exposure to corrosive substances. Commercial sites, on the other hand, may be able to use less expensive wiring methods, such as electrical metallic tubing or non-metallic sheet cable, in some areas. The proposed definitions could also affect the requirements for emergency power systems in different types of buildings. For example, hospitals and other healthcare facilities are typically required to have emergency power systems that can provide backup power for critical loads, such as life support equipment and operating room lighting. Commercial buildings that house large numbers of occupants, such as office buildings or shopping malls, may also be required to have emergency power systems to provide lighting and other essential services during a power outage. Industrial sites may also require emergency power systems to maintain critical processes or prevent damage to equipment in the event of a power failure. The specific requirements for emergency power systems in each type of occupancy are typically based on the size and complexity of the building, the number of occupants, and the potential hazards present. Therefore, it is important to carefully consider the applicable code requirements when designing and installing emergency power systems in different types of facilities. Another area where the proposed code changes could have an impact is in the design of fire alarm systems. Fire alarm systems are designed to detect fires and alert occupants of a building, allowing them to evacuate safely. The requirements for fire alarm systems vary depending on the type of occupancy, the size of the building, and the potential hazards present. For example, high-rise buildings and other large commercial buildings are typically required to have more sophisticated fire alarm systems than smaller buildings. Industrial sites may also require specialized fire alarm systems to detect fires involving hazardous materials or processes. The proposed definitions of industrial and commercial sites could help to clarify the requirements for fire alarm systems in different types of occupancies. It is important to note that the NEC is not the only code that governs electrical installations. Other codes, such as the International Building Code (IBC) and the International Fire Code (ISC), may also contain requirements that are relevant to electrical systems. These codes are often adopted and enforced by local jurisdictions, so it is important to check with the local authorities to determine which codes are applicable to a particular project. In addition to complying with the applicable codes, it is also important to follow accepted engineering practices when designing and installing electrical systems. This includes using appropriate materials and equipment, following manufacturer's instructions, and performing thorough testing and commissioning to ensure that the system is operating safely and effectively. The NEC is a complex and constantly evolving document. It is important for electrical designers, installers, and inspectors to stay up to date on the latest changes to the code to ensure that electrical installations are safe and compliant. The proposed code changes discussed here are just a few examples of the many changes that are being considered for the next edition of the NEC. It is important to review all of the proposed changes carefully and provide feedback to the code-making panels to help ensure that the NEC is as clear, accurate, and effective as possible. The NEC is a living document that is constantly being updated to reflect new technologies, changing safety standards, and lessons learned from past incidents. By actively participating in the code-making process, electrical professionals can help to shape the future of the NEC and ensure that it continues to protect people and property from electrical hazards. Furthermore, understanding the NEC is not merely about rote memorization of rules, but about grasping the underlying principles that guide safe electrical practices. These principles include proper grounding, overcurrent protection, conductor sizing, and insulation. A thorough understanding of these principles allows electrical professionals to apply the NEC effectively and make informed decisions in complex situations. Moreover, the NEC provides a framework for electrical safety, but it is not a substitute for sound judgment and careful workmanship. Electrical professionals must exercise their expertise and experience to ensure that electrical installations are not only code compliant but also safe and reliable. This includes considering the specific conditions of the installation, the potential hazards present, and the needs of the occupants. In addition to the technical aspects of the NEC, it is also important to understand the legal and ethical responsibilities of electrical professionals. Electrical professionals are responsible for ensuring that their work meets the applicable codes and standards, and that it is performed in a safe and professional manner. They also have a responsibility to protect the public from electrical hazards and to act in the best interests of their clients. Electrical safety is a shared responsibility, and it requires the cooperation of everyone involved in the design, installation, and maintenance of electrical systems. By working together, electrical professionals, building owners, and code officials can help to create a safer environment for everyone. It is essential to remember that the NEC is a minimum standard, and that it is often necessary to go above and beyond the code to ensure electrical safety. This is particularly true in situations where there are unusual hazards or where the consequences of an electrical failure could be severe. In such cases, it is important to consult with qualified electrical engineers and other experts to develop a comprehensive safety plan. Furthermore, continuous learning is critical for electrical professionals to stay abreast of the latest technologies, codes, and standards. Participating in continuing education courses, attending industry conferences, and reading trade publications can help electrical professionals to maintain their knowledge and skills. In conclusion, the proposed code changes to Section 406.9c and Article 100 definitions highlight the ongoing effort to refine and improve the NEC. These changes reflect a commitment to enhancing electrical safety and ensuring that the code remains relevant and effective in addressing the evolving needs of the electrical industry. By understanding the rationale behind these changes and actively participating in the code-making process, electrical professionals can contribute to a safer and more reliable electrical infrastructure.